All right, boys and girls, today's lesson is lesson 2-16. And we're getting bigger, we're stretching it. It's multiplying one digit by four digit numbers. So because we were so good at one digit by three digit, one digit by four digit should be pretty easy for you. But real quickly here, I want to show you this 7 times 3,000. And I want you to tell me how it relates to 7 times 300. So look at these two and see how they relate to each other. And write it down in your math notebook. Well, hopefully you said that 7 times 3,000 would be 10 times 7 times 300. Because you have another zero. If you jump up just one more zero, that just means 10 times more. If there were 2 zeros, maybe 100 times, 3 zeros, 1,000 times more. That's just 10 times more. So, I'm going to shove that away and have you turn to page 77 in your math notebook, and you're going to see how 7 times 3,000 looks. Okay, so I know a lot of you can just say, oh, it's easy, 7 times 3 equals 21, and then I'll put the 3 zeros back on, and they'll give me 21,000. But, as you know, when it comes to our math, we like to really break it down so you can visualize it, so you can see it. So here it says you can use a model to multiply greater numbers. Notice that each of the smaller rectangles in this model represents 1,000. Each of the columns represents 7 1,000s. So if you look, there's 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000. So each group here represents 7 1,000s. There's 7 1,000s here, 7 1,000s here. Each row has 3,000s. Not the straightest lines, but I just want you to understand that it's going and it's continuing to go. So, if you look at it, 7 times 3,000 equals 7 times 3 times 1,000, which equals 7 times 3 times 1,000, which equals 21 times 1,000, and you know 21 times 1 is 1, and put the 3 zeros back on. So, while multiplying thousands, how many zeros can you expect in the product? Okay, if you're multiplying thousands, you should have at least 3 zeros. So you should have at least 3 zeros in the product. Does that mean you always have zeros on it every single time if you're multiplying by whole thousands? Yeah. If you're multiplying by 1,000 or 2,000 or 3,000 or 20,000 or 30,000, if you're just multiplying by straight thousands, yes, you should have at least 3 zeros. If you're multiplying by 1,123, you may not see any zeros. But when you're multiplying by thousands, strictly thousands, like 1,000 or 3,000, then yes, you'll have at least 3 zeros. So how does thinking of 3,000 as 3 times 1,000 help you multiply 7 times 3,000? Well, hopefully you know that since 3,000 equals 3 times 1,000, I can use the associative property of multiplication to group the factors in different ways. So I can do 7 times 3 times 1,000 to equal 7 times 3 times 1,000. And that makes it pretty easy because you know 7 times 3 is 21 times 1,000 would just be adding 3 zeros on the end, give you 21,000. So if you were to draw a model for 4 times 8,000, what you would want to do would be pretty easy. You could just do this. 1, 2, 3, 4, 5, 6, 7, 8. So this would be 4 times 8,000, which 8,000 I'm going to break into 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000, 1,000. And of course there's a plus in between each of these, because that's basically what 8,000 is. So each of these would equal 4,000. So you would know that if there are 8 4,000s, 8 times, I'm sorry, we'll do 4 times 8 times 1,000 would really be equal 4 times 8 times 1,000. 4 times 8 is 32. Put the 3 zeros on, and you get 32,000. All right, so we spent all this time working with kind of the easy multiplication when it comes to 4 by a 1 multiplication. So let's work on different methods, okay? Let me push this all out of the way. And let's do 9 times 6,435. All right, this is when we get our squares in here. Our rectangles, 6,435 equals 6,000 plus 400 plus 30 plus 5. Okay, times 9. And this box is 9 times 6,000, which equals 54 with 3 zeros, 54,000. This equals 9 times 400, which equals 9 times 4 is 36 with 2 zeros. This is 9 times 30, which equals 27 with 1 zero. 9 times 5, which equals 45. And then you'd add them all together. Make sure you line them up when you add them up together, because I've been seeing way too much of people not lining them up correctly, and then they get the answer wrong and say, what did I do wrong? Okay, 0 plus 0 plus 0 plus 5 is 5. 0 plus 0 plus 7 plus 4 is 11. Carry the 1. 1 plus 6 is 7. 9, 7, 54, or 57,915. All right? So I know we can use multiple methods to solve it. So let's look at the expanded notation method, where we start drawing the arrows, because this would be more of the place value sections method, because we're showing the place values in each section. So let's do it one more time. 9 times 6,435. We draw our fancy rectangle. We do 9 here. We do 6,000 plus 400 plus 30 plus 5. I'm going to write over here just to show myself. And what we're doing is, you can write the 9 over here, because it's 9 on each side. It doesn't really matter how you do it. So if you want to draw the arrows, you could say, I'm going to take 9 times, or 6,000 times 9, 4,000 times 9, 30 times 9, and 5 times 9. If you worked all that out, you would see that 6,435 times 9 would equal 6,000 plus 400 plus 30 plus 5 times 9. If I draw my line, I'm going to have to slide this up a little bit. You're going to see 9 times 6,000 equals 54,000. Notice I'm lining them up along each other. 9 times 400 equals 3,600. 9 times 30 equals 270. And 9 times 5 equals 45. And once again, if I add them all up, I'm going to get 57,915, just like before. So those are your two options, I think. You can either do the expanded notation like this. You can also draw the arrows to where they might go from this side on each, however you want to do it. The arrows help you, and then to multiply them, and you show your work below, and you're going to get 57,915, most likely every single time. So, hopefully you would every single time, but let me get this out of the way. I'm going to shove this out of the way, and I want you to turn to page 78 in your math activity book. Okay, it says compare multiplication methods. Okay, it says you can use multiplication methods you have learned to multiply one-digit number by a four-digit number. Okay, you have the place value sections method. Okay, where we do all the work in the boxes, and then we add them all together down there. Like that. And then we have the expanded notation method, where we are basically drawing the lines, or the curves like that. And that's what we're doing on expanded notation. An algebraic notation method, where we're similarly drawing the lines from the other 8 to each. And it basically, all the work you show, okay, as you can tell, In place value sections method, you're just taking the total you got in each box. Here, you're breaking it apart and pretty much showing the total that you got in each box. Then the expanded notation, or the algebraic notation method, is a little trickier, where you're taking each of them, each partial product, pulling them apart, and then you're taking them, add them all together. It looks different. But boys and girls, all these things will equal the exact same. So I want you to make a rectangle drawing for each of these problems. You can do it inside your math notebook. Should be easy. All you're doing is add an extra square. Let's do. I'll show you number 4 here. We have 3 times 8,153. So then we know 8,153 equals 8,000 plus 100 plus 50 plus 3, times it by 3. Okay, so then we get 8,000 times 3 here. We get 100 times 3, 50 times 3, and 3 times 3. Multiply each of these, add it all together, you get your answer. So work on number 4 through 7 on your own, and then we'll talk more in small group.